All right, so the first thing I have to do if I'm going to use double false position is take the two boundaries, 5 and 6, substitute them into the formula that I'm given, and find its corresponding y value. So in the first one, if I have that my x is 5, and I've substituted that in everywhere, I'll get that its corresponding value is -2. And if I substitute in 6, I'll get that its corresponding y value is +2. Now I can use my double false position formula to find a better approximation of my x. So if I say that my new x is going to equal, and I got is my second x value times my first y value minus my first x value times my second y value all over my first y value minus my second y value. And if I simplify this, I will get 11 halves. So I'm going to keep them as fractions to keep my answers as exact as possible. So if I think that's my x, so now if I'm looking at x3 and say f of x3, this will be 11 halves, comma, when I plug that into x squared minus 7x plus 8, its corresponding value becomes -1/4. So if I'm going to do a second iteration, I'll look and say, okay, the y value is negative, so I'm going to replace this value with my new ordered pair and do it again. So when I look at this now, I'm going to replace this with 11 halves, comma, -1/4, and I'm going to keep this one as 6/2, so that I'm on both sides of that graph when I'm thinking about trying to get that root. So now I can say again, I'm going to find that new x value. It's always my second x times my first y minus my first x times my second y all over my first y. Let's fix that. Minus my second y. And if I simplify this, I will end up with 50/9, and that's approximately 5 and then the repeating 5s. And you can go in and actually see if you graph this that it crosses right around that point. And if I do another iteration, I'd get even closer to that actual value. For this quadratic equation, x squared plus 2x minus 6 equals 0, I'm looking at the root between 1 and 2. So first thing I'm going to plug in 1, its corresponding y is -3. I'll plug in 2, its corresponding y is +2. So now I can use my first iteration of my double false position. I take my second x times my first y and subtract my first x times my second y all over my first y minus my second y. And this will give me 8/5, or approximately 1 6/10. So now let's see, its ordered pair then, if I think about x3 and then f of x3, when I do that, I'm going to get 8/5, comma, and then I'm going to get -6/25. Since that's negative, I'll look and say I'm going to replace my first ordered pair and do this again for my second iteration. So now I'm looking at 8/5, comma, -6/25 for my first ordered pair, and my second ordered pair will still be 2/2. So now I can do a second iteration with my new values. So it's again my second x times my first y minus my first x, 8/5, times my second y all over my first y minus my second y. And when I simplify this one, I get 23/14, which is approximately, and it's a long repeating decimal, so we'll just do the first couple decimal points, 8, 5, 7, ... And if you look, this gets within a couple thousandths of if you actually graph this now. So think about what they're able to do without calculators, without graphing, able to use formulas such as this.